Okay, in this video I'm going to just discuss day 2, part 2. So if you watch the part 1, you'll see that I actually completed the lessons in part 1 for topics A to topics G, which stopped at distributive property. What I'm going to talk about in this short video is just the section on topic H, which is looking at one-step, two-step equations, brackets, like terms, and also solving for fractions. So, something that you might recall from when you initially took this, with algebra, there is this idea of always performing the opposite. I'll write it on this side. So the opposite in operation, which is also known as the inverse operation. Okay, so what that means is, if we were to take the opposite operation, I can take the idea that we were discussing earlier. We were talking about BEDMAS. Okay, so anytime you are simplifying or evaluating, there's always this sense of working through BEDMAS, where from left to right, you do brackets, exponents, division, multiplication, addition, subtraction. In algebra, we actually don't follow BEDMAS, but for one and two step equations, we do backwards. Okay, so instead of it being BEDMAS, we work through something called SAMDEB. Okay, so in one and two step equations, having a look to see is there any subtraction or addition, and if so, apply the inverse operation. If there's any multiplication, if there's any division, if so, apply the opposite operation. Okay, so when you're doing these questions in this course and in your homework selection, and even for your math journal, you got to make sure that you're showing your full steps. Okay, so you're not just simply going to say x equals the number that you think it equals. Okay, so one off backwards. So the opposite inverse operation of addition we know is subtraction. So if it's saying x plus 5 is equal to 9, what I'm going to do is I'm really going to subtract 5. And I'm going to do that to both sides. So you'll notice the plus 5 minus 5 will cancel. And I'll just have x is equal to 9 minus 5, which would be 4. Okay. The opposite operation of subtraction will be addition. So then we'll take a look at x minus 1 is equal to 3. And instead of subtracting 1, I'm going to add 1 on both sides. So x should be equal to 3 plus 1, which is 4. Okay. For multiplication, the opposite of multiplying is division. So 2 times a number, I'm going to take both sides and divide both sides by 2, or x is equal to 5. Opposite of division is multiplication. So if we have x over 2 is equal to 6, we're going to multiply both sides by whatever the denominator is. So in this case, I'm going to go times 2 times 2. You'll notice any number over itself will cancel. And I'm left with just x is equal to 12. And last but not least, the opposite of squaring. Okay, so when something is raised to an exponent 2, the opposite is to actually square root. So instead of x squared is equal to 9, to isolate for x, I'm going to actually take the square root of both sides. When you square root a square, which is the x squared, that just becomes x. Okay, and what we'll do is we'll do the same thing to the right side, so the square root of 9 is equal to positive 3. Okay, so with these one-step equations, again, I don't want you to just say what the answer would be, right? This one easily, we can say x is equal to 8, although yes, that's the correct answer. You want to make sure you show your full steps to get full marks and make that very clear and evident in your math journal that you create. Now, we did the opposite operation for all of these examples here in the top row. Another way you can also do it is, I call it the wall method. Okay, so think of that equal sign as a very special wall, and anytime any terms cross that wall, whether it's going from the left to the right or the right to the left, it changes its operative sign. Okay, so for instance, if I want to do the addition example, I'm going to take this plus 10, I'm going to isolate for x. So isolate means get x by itself. So I'm going to take that plus 10, I'm going to bring it to the right side. So that's going to be 31 now minus 10 because it's going to change its opposite operation. And then x will now be equal to 21. If you want to do it the way that I showed you above in that first row, no problem. You can do that. I just also want to show you another way that you can complete questions with addition and subtraction. Okay? So same thing for here. We're going to take this wall. I'm now going to move -8 so I can isolate x, bring it to the other side. So I now have x is equal to 2 plus 8 because that -8 turns into a positive once I cross that wall. And I have x is equal to 10. I'll leave those last three examples for now, and I'll move on to the next thing. So this is just one-step equations, okay? Now for your two-step equations, you're going to do the exact same format. There's just going to be more steps, okay? So again, considering SAMDEB, BADMAS backwards. Okay, so we'll check the equation. Is there any subtraction or addition? Well, you'll see there's a plus 8 or addition of 8. I'm going to do the wall method, where I'm going to bring it over the equal sign. That on the left side will just be 2x is equal to 20 minus 8. I'm going to subtract 20 minus 8. I'm going to get 12. Okay, so again, it was addition, but the opposite of addition is the subtraction I just did there. Okay, then to isolate for x, I'm going to divide both sides by 2, divide both sides by 2. I should get x is equal to 6. We'll try another one here. So for this one, I'm going to bring the 5 over. Now that negative x didn't move, so that means that sign of x is still going to stay at negative, right? Or there's a negative 1 in front of that x. So that's not going to change. I'm going to have 11 take away 5 because that positive 5 is physically moving to the other side of the wall. And then you might stop and say, well, does this mean that I'm done because I technically have x is equal to a number? However, you're not done. You need that x to be positive. It's asking what is the value of x, not what's the value of negative x. So to get that, I need to get rid of that coefficient. Remember, the coefficient of x, in this case, is actually going to be -1. So I'm just going to divide both sides by -1. And there we go. Okay. For ones with brackets, okay, so your steps are here. Okay, so you're just going to apply the distributive property like we did, and then afterwards it actually just becomes a two-step equation. Now so far the examples have been pretty straightforward in the sense where your answers are pretty much whole numbers. There are times when your answers might be a fraction for the much more trickier examples. They don't come often, but I want you to be aware of it, that it is most likely a good idea to just leave it as a fraction. I'll show you how to do a left side, right side check, which actually brings me to the second question. So whenever it says to solve and check, okay, the solving part we know, we've been doing that for the last couple of minutes. So I should have 10x plus 8 is equal to 68. Okay, I then take this plus 8, I do my wall method, I bring it over the equal sign. It now becomes subtraction of 8 or minus 8. Then I divide both sides by 10. X is equal to 6. Okay, so you've done the solve part. The check part is you making a left side, right side check. Okay, so it's going to be a T table where we're going to rewrite what's on the left side of the equation. So in this case, in the original, of course, so 2 times 5x plus 4. And on the right side, I'm going to write what's on the right side, so in this case, just 68. We're going to take what we got as our answer, and I'm going to sub it in for x. Okay, so really what this reads is 2, open bracket, 5 times 6 plus 4. So 5 times 6 is obviously 30. 30 plus 4 is 34. 2 times 34 is 68. Once you notice that your left side does balance with your right side, you can say, therefore, x is equal to 6, verified by left side equals right side check. Okay, so in your assignment that's coming up, if you are asked to do a left side, right side check, which you most likely will be asked to do, you have to write your therefore statement. This is very important. That fully answers and verifies your question. Okay? Alright. So that takes care of the brackets example. Okay, so just going back up here to the top. There's like terms and fractions that we also need to discuss. Okay, so with like terms, sometimes you got to do a little extra work in first collecting your like terms like we did in the earlier video. I'm just going to use a highlighter just to group everything nicely. You're welcome to do this at home. Okay, so you can see my constants are all the same color, and my variables, so x, are highlighted together as well. So I should have 8x plus 9 is equal to 49. Okay, so I've collected like terms, which is my step 1. And then step 2 is just to solve for x, like we've been doing the last couple examples. So with my wall method, I'm going to bring that plus 9 to the right side. So I should have 8x is equal to 49 minus 9. 8x is equal to 40. Divide both sides by 8. X is equal to 5. Okay, so pretty straightforward. You just have to be aware of which terms are alike. So remember, group all your variables together, group all your constants. Keep in mind at least one of two of the rules. So either you're going to do the inverse operation, where you just do the opposite action of what's presented to you, or you can do my wall method, where whatever term you take, you bring it to the opposite side, and it takes the inverse operation. Okay. All right. So same with this one. You can do this one, solve and check the following equation. I'll get you guys to give that a try to see if you can do your left side, right side check. Okay. So that took care of solving equations with like terms. We're going to do the one with fractions. Okay, so fractions, this is going to be the most trickiest version of solving for x. Okay, so for solving equations. And the reason why it's so tricky is because there's so many steps. Okay, so you're actually, sorry, these are misnumbered. That'll just be 1, 2, 3. Okay, so what we're going to do is we're going to determine the lowest common denominator for all the fractions. Okay, so if I were to evaluate 6 times 2 over 3, like we did in our review, I actually would have put that over 1. Okay, and the steps actually, you know what, the steps apply to just solving the equations in the questions we'll do following this. This is just a warm-up. So if we were to multiply numerator, numerator, denominator, denominator, we would actually have 12 over 3, which is equal to 4. Okay, so in this one you don't need a common denominator. And the reason why you don't need a common denominator is because you're multiplying. Where it becomes very evident, so more so where these steps do apply, is for questions where we're adding or subtracting. Okay, so you have to determine the lowest common denominator for all the fractions. So if you look at each denominator here, I have a 2, I have a 3, and I have a 6. How to find your LCD? So what I'm going to do is I'm going to think about what denominator do they all have in common. I'm going to agree that my LCD is 6. Okay, so what we're going to do is we're going to multiply our LCD to each term. Okay, so we're going to do 6 open bracket x over 2 minus 6 open bracket 1 over 3 equals 6 open bracket 13 over 6, which pretty much has some similarities to what we did in the above example. Okay, so remember, all of these are just over 1. Okay, now I'm going to show you a shortcut to help with multiplying with fractions. Okay, so if that's really just 6 over 1 multiplied by x over 2, really all I'm doing, and I can do this as a cross out multiplication, not cross multiplication, but like a cross out, is 6 divided by 2 is 3. And then just multiply that with x. So that will be 3x. Okay, now the denominator didn't matter because either way, if I was to do this using the example that I did right above, it would just be 6x, because 6 times x, divided by 1 times 2, which would be 2, and you simplify, and that would just be 3x. So you get the same thing, just a shortcut. Okay. Okay, we'll do the same thing here. 6 divided by 3 is 2. 2 times 1 is just 2. 6 over 6 cancels, so that's just 1. 1 times 13 is 13. So now I have no denominator. It's straightforward. I'm just going to solve for x. Okay. Now the whole purpose of multiplying by your LCD is to eliminate that denominator. So x should be equal to 5. Okay, these are going to be the trickiest ones in your example A and B, but again, it's very good to try, and let me know if you have any questions, okay? So that pretty much wraps up the section H, which is one-step, two-step equations, brackets, like terms and fractions. Please let me know if you have any questions in relation